Okay, this one we're gonna have to learn how to deal with images. If you're going to do neural network, you need to know how to deal with load images so you can train with. Okay, type def structure type image. It's almost the same as a bitmap, but it's just an image. Okay, unsigned long. Okay, image width, unsigned long, image height, unsigned long, no, okay, long, image length. Length is the number of pixels, and then we also need the size of the image in bytes. Image size. Okay, now we got, is it void? Oh, whatever. Unsigned long pointer image data. Okay, now we have an image. I prefer to align it, but it really doesn't matter. Okay, now we need create the image. Type the, no, not type the structure. Long. Okay, no. Type image. Trying to do all this from memory is really not working. Type image create. Okay. Type image. No, not image. Parent. Unsigned long width. Unsigned long height. Okay. Now we need to create an image. If parent equals 0, return 0. Okay, it's just basically the same as neural array. We allocate a memory, and then if it doesn't work, we return. Okay, void data. Unsigned long length. Unsigned long data length. Okay, now we need to calculate the length. Okay, length equals width times height. Okay, data length equals length, not equals, what am I doing? Equals length times size of, not size, size of data length, not data length, length, size of unsigned long. Okay, I'm getting confused here. Okay, data equal malloc, two L's, malloc data length. Does it work? If it works, then if data, that means everything worked right. Now, parent dot image width equal width, parent dot image height equal height, parent dot image length equal length, parent dot image size equals size, and parent dot image data equal data, not size, data. How am I doing? Data size. Not data size. Data length. I've probably forgotten data length. I've forgotten the length of my variables. Okay, unsigned long pointer data. Okay, everything's good. Return 1. Alright, so now we have an image. Or we also have to check if it doesn't work. So we put everything to 0. Everything equals 0, return 0. Okay, now we delete it. Always be sure to create and delete so that we don't have memory leaks. Okay, type image delete, destroy. Type image. Okay, what am I doing here? Okay, type image parent. Okay, we copy and paste this part right here. And this part, if parent equals 0. Don't do this to me. What is it doing? Okay, that's working. Okay, free parent image data, and we're done. And also return 1. Okay, why is it saying there's an error? Expected. Oh, there's an error here. Okay, there's an error. Okay. Okay, of course, align everything. Advanced format document. Okay, we have an image. What else do we need? Okay. So I'm going to put it aside just to make sure. File new. File. Add a file. Okay, if and def. No, don't do this to me. If and def type image. Define type image h n f. Okay, so now copy everything. We're gonna have to do a lot of other things to it. Cut and paste. Where am I? Oh, no, not here. Not here. Okay. Okay. Okay, type image. Just copy everything. Make it visible. Okay, this is part 1. Okay, now for part 2. Oh, still have to save it. Okay, type image dot h. Okay, now for part 2. We have to load a BMP file. It's gonna be complicated. Okay, step 1 to loading a BMP file. Okay, long type file BMP. Okay, read. Oh, just call it load. Load and save. Okay, we're gonna load it into an image. Type image parent. Okay, char file name. Okay, now you have to figure out what the format of a BMP file is. Okay, I've been reading on Wikipedia. Okay, BMP file format. BMP file format. When in doubt, just Wikipedia. Okay, so we just read all this here and then load each thing 1 byte at a time. It shouldn't be too difficult, except for this part right here, the pixel storage. Okay, I'm gonna read up on this and figure out how to do this. Okay, yeah. Type. Oh, we don't need neural right yet. Type image. Okay. Do I need something else? Oh yeah, stdlib. Include stdio. If you want to do if you're gonna deal with files, we need stdio. Not that. What the hell am I doing? Not that. Whoa! I can't see anything. Ah, it's 3. It's dark in here. My keyboard doesn't work right. The illumination on my keyboard doesn't work right. Okay, SDIO, so we need a file. Okay, so let's read from the file. We're gonna get out of errors. File FP. Okay, if fopen. Okay, I need to open the file. Yeah, last time I tried this, Visual Studio gave me some weird error about fopen, so we have to use fopen s. NFP. fopen s is the secure version of fopen, and if you don't use it, Visual Studio it tells you it's not secure. It's just annoying, but I'm not sure if it's important in every file. Okay, file name, and we need to read byte LB read byte. If fopen not equals 0, oh, it returns a 0 if nothing went wrong, which is weird. Okay, this is backwards. It returns 0 if everything. Whoa! If fopen b not equals 0, return. Okay, next. Okay, we need. Where was I? We need to read the structure of the file. Okay, the structure is okay, I'm gonna read up on this one moment. Wait a moment. I'm gonna read up on this. Okay, I got it. It's Bitmap info header. Okay, it's Bitmap info header. This is what I got from the documentation here. Okay, we have the bitmap file header, bitmap info header. It's the same as bitmap, and we have to load every part of it. Oh, and one more thing I forgot about reading from my BMP file. You can't just read the bytes exactly as they are, because there's something called endianness, and you have to read the bytes in a different order than what you would expect, the way they're stored in memory. So we have to, okay, static unsigned char to read the byte. Read byte. Okay, we read byte. Standard read byte file. File pointer FP. For read byte, we just return f get c, f get character. So this returns us one single byte from the file. This is the simple part. After that, it gets more complicated. Okay, to read a word. What am I doing? Oh, unsigned char. What am I doing? Read byte. Oh, okay, read byte. Okay, read word. A word is 16-bit 2 bytes. But once again, it's not stored in a one after the other, in a byte one after the other. So first we read the first byte. You can't just read both bytes at once. So you have to read one byte at a time. First you read the read byte, and then you OR, an OR operation. Copy it, f gets c fp, and you shift it right by 8. So in memory, it's the second byte comes first. This byte here comes first. In memory, this byte here comes first, but in the file, the second byte comes first, and then everything's backwards. Shift left 8. You have to shift the byte left by 8, and then to get everything in the right position. That's the problem with endianness. Okay. Now the even more complicated one, read double word. So now we have 4 bytes, and they come in a weird order. Okay, we have the last byte is the first byte, so everything's backward, and then we have the second byte. We have to shift it left by 8. Oh, the second to last. The second byte is the second to last. So everything has to be reversed. Okay, here shifted left by 8. Here you shifted left by 16. And then the last one, you shifted left by 24. Okay, so the order of the bytes have to be reversed. That's something, yeah, that gave me a lot of trouble at one point. Okay, remember this. The bytes come in the opposite order that they are stored in memory. Okay, now, next thing. Okay, BF header. Okay, second thing you need to remember is that you cannot read a structure from a file directly into memory, because something called byte alignment. If you have a structure made of 2 bytes, then it's actually stored as 4 bytes, because in a 64-bit computer, in a 32-bit or 64-bit computer, you have to align the bytes. In a 64-bit, it takes up a 2-byte structure takes up 8 bytes, and everything has to be lined up. If it's not, the computer gives you trouble. So the size that it's stored in the file is not the same as what's stored in memory. So you have to read everything 1 byte, one structure at a time. One byte, 2 byte, 3 byte at a time. So yeah, you can just get it in a single operation. Okay, BF header dot tf type. That one's read. I'm reading from the documentation here. Word. You have to get it in the right order. FP. Okay. I just copy it so I don't have to. Okay. Oh no, we have to copy this one. Okay, BF header dot. Which one? Oh, size. Okay, I'm reading from the documentation here and read word FP. BF header dot reserved 1 equals, you can't skip anything, read word. So it's important not to get this wrong, because if you read word when you're supposed to read a byte, then everything's gonna be misaligned and the whole thing will fail. So you can't get this wrong. Oh wait, and I got it wrong. It's double word. This is a 32-bit one. The size one's 32-bit. Okay, read word again. Reserve 2. Read word of bits. BF of bits equals read double word, the offset bits. Okay, next. You have to be very careful not to get this wrong. If BF header dot BF type not equals, okay, what's the signature? Wait, oh, I got it. 0x4D42. You have to make sure it's the right file. Break, return. Okay. Oh wait, we can't return 0 because we already opened the file. We have to close it. So oh wait, this doesn't work. Okay. While 1. Let's go into an infinite loop. No, while 1. Okay, so to keep things, no, we have to go into an infinite loop here. Okay, we break out. Okay, F close. F close FP. We have to close the file before we go. And return 0. Okay, F close and break. Okay, return 0. That means we failed. Okay, break. That means everything's wrong. Okay, BFM4 dot BI size equal read double word FP. Okay, this one's gonna take a while. Okay, what am I doing? No. Okay, BFM4. Let's copy this. BFM4 dot bi width equal read double word FP. Maybe I should copy the whole thing. Let me pause and do this and do this offline because it's gonna take way too long. And we're done. Yeah, it's just tedious. You just have to copy everything. If BFM4, not BFM4, you just have to follow the documentation. BFM4. Oh my god, what am I doing? If BFM4 dot bi compression not equals 0. Okay, we cannot load a file that is not compressed. Break. Okay, now we can start loading the image. Okay, bytes per pixel. Okay, let's read from the documentation here. Okay, the procedure for loading it. Okay, bits per pixel, image width. Okay, row size. Okay, I'm gonna have to stop and read this. Okay, I got the code here. Okay, so we need to calculate the bytes per pixel, and which is okay. This part gets really complicated here. While to figure that one out. Okay, the bytes per pixel is how many bytes per pixel exactly we have to read, and then the padded row size. The way it's stored is that each row is not exactly the same as the width and height of the final image. So it has to be aligned in 4 bytes. So we divide by 4, then multiply it again by 4, and take the ceiling value, the long value, the padded row size. So this gives us how many bytes to read, and it's not the same as the final image. So now we can start loading the image. Okay, we need to load the length of the image. Oh no, unsigned long. Unsigned long length equals BFM4. BFM4 dot bi width times BFM4 dot bi height. Okay, that gives us the length of the image. Okay, data length. Data length equals size of, no, what am I doing? Equals size of, and then GTH, and length times, wait a minute, no, size of, wait a minute, data length equals, oh no, size of unsigned long. Trying to create the image here, times length. Okay, buffer, we have to allocate buffer, which is, yeah, unsigned buffer equals, okay, malloc, allocate data length. Yeah, it gives me, this is just being annoying again. I make a point to treat all warnings as errors, so just to be safe, whenever it gives an error, you have to correct it. Otherwise, it could turn into a mistake. Okay, now you have to buffer. Okay, if buffer equals 0, oh no, there's nothing to do. Break. Okay. Okay, for we need an I, JK, unsigned long I and J. Okay, for I equals 0, I less than BI. Oh no, J equals 0. BI height J plus plus. When counting in a linear, we have to do the second counter first, and then in a loop we do the inner counter, the first counter. Wait, not second, the first counter first. Okay, fseek. Okay, okay, we need to go into the location of the data now. We have read all the information. Now we need to look in the location of the data. FP. Okay, BI off bits. BF header dot BI of bits. The offset of bits is just in the file plus. Okay, that's why BF info. Oh, dot BI height. Okay, doing those calculations on live is just really tedious. Plus 1. Okay, times. Okay, padded. Padded row size. Okay, let me correct this. Padded row size. 6Z. Okay. Okay, I should give us the location of the starting bytes. Okay, 4. We have to go to every pixel in the image. For I, why am I doing I equal 0? That's a mistake. For I equals 0, may have to correct those mistakes later. For I equals 0. Okay, this part is just tedious. Let me just finish this. Okay, after lots of trial and error, I finally figure out how this works. Okay, let's see if I get it right. Okay, I think I got this right. Okay, what do we do? We seek into the data, and then for each pixel we read the whoa. Okay, we read the RGB values. If it's one bytes per pixel, then obviously it's just one pixel. The RGB. I just read it all at once because otherwise we get uninitialized variable warnings, and I don't like that. Okay, for 3 bytes per pixel, just read RGB. For 4 bytes, we just read all 4 bytes, and we only use the R, the G, and the B. So we store the whole thing into a buffer. Okay, now that we have the buffer, what do we do? Oh wait, there's K plus plus. I forgot something here. Not K, it's not plus plus. It's K plus equal. We have 4 bytes in the buffer. 4 bytes for one buffer, so it's K plus 4. K plus equal 4. Okay, now that we have the buffer, what do we do with it? Okay, now we have to create an image. Okay, if type image create. Now we create the image parent. BF header BF info dot BI width. BF info dot BI height. Okay, but BI height, and completely forgot about something. Okay, I'm gonna work on something else for a moment there. Actually, I said it's not really worth it. So this right here gives you how to load an image into a buffer. The next part is just put the image from the buffer into an actual image. Okay, we load it into memory, but I'm not sure what to do with it after that. I'm gonna have to figure it out in the next video. So anyway, we know how to load an image from a BMP file. Next time we're just gonna load it into a structure that I can use and test it. That's pretty much it for now.